The transportation sector accounts for 28% of greenhouse gas emissions, and heavy-duty trucks account for 23% of that. And even though transitioning passenger cars to electric is well underway at this point, we're just at the beginning of transitioning trucks and semis. But there's a major wrinkle. While EVs are far more energy efficient than gasoline vehicles, towing a lot of weight takes a major hit on efficiency. Let's explore the future of electric trucks and just how well batteries stand up to diesel. I'm Ferrell. Welcome to Undecided. Heavy-duty trucks are one of the backbones for shipping goods around the world, but they're usually powered by noisy diesel engines, which means they're also creating a lot of pollution. In the US, transportation is the largest contributor for greenhouse gas emissions, and from a worldwide perspective, diesel truck engines account for 5% of global fossil fuel-derived CO2 emissions. But there's a wave of electric trucks and semis that are coming to market to address just that. And when you look at how gasoline compares to battery electric vehicles for energy use, it's pretty clear that EVs come out on top. The fantastic YouTube channel Engineering Explained has a great video breaking down energy and range comparisons between battery and gasoline, as well as towing impacts. I'll include a link here in the description, so be sure to check that one out if you're interested in the math that goes behind all of this. But in a nutshell, a 200 kilowatt-hour Cybertruck would have a range of about 500 miles versus a Ford F-150's full tank, which provides the equivalent of about 775 to 1200 kilowatt-hours of energy, for a 437 to 684 mile range. That's quite a gap going from 200 kilowatt hours to 775 kilowatt hours for roughly the same range. So obviously on an efficiency basis, battery wins there. But that's where the big challenge comes in. That's under ideal conditions for just the vehicle. When you start towing tens of thousands of pounds of cargo, the range of EVs takes a much bigger hit than the gasoline competition. When towing, the range of a gasoline truck is a little over double the capability of a battery electric truck. They may be more inefficient, but that sheer energy density in the tank of diesel makes up for it. For electric trucks and semis to be really competitive, they need to double their energy density of their battery packs. Or do they? In 2017, Elon Musk stood on stage and announced the Tesla Semi, which most people are expecting to be the major market disruptor. This all-electric semi-truck should be somewhere between 300 to 500 miles on a single charge, while consuming less than 2 kilowatt hours per mile. Now that's impressive. And to do that, they're going to be taking advantage of Tesla's new 4680 battery cells. But even with those cells, it's going to require an absolutely massive battery pack. We're talking about 5 to 10 times the battery capacity of a typical Tesla car. And while the Tesla Model 3 has a battery pack capacity that ranges between 50 kilowatt hours and 82 kilowatt hours, semis might range all the way up to 800 to 900 kilowatt hours. On that exact topic, Elon said, "You want something in the order of probably a 500 kilowatt hour pack. What we have in the Model S and X is a 100 kilowatt hour pack, and probably something like a 500 kilowatt hour pack in the Tesla Semi." Again, that's only in reference to the 300 mile version, and is another catch of battery electric trucks. Not enough batteries. The massive battery pack and number of cells needed is one of the reasons for the Semi's production delay. When asked about the Semi's launch timeline on Twitter, Elon said, "We are too cell constrained right now, but probably okay next year." Earlier reports said the company was planning to start building about 5 semis a week in a new pilot line that's near the Nevada Gigafactory later this year, and add to that announcement from Pepsi that they're expecting to be using 15 Tesla semi-electric trucks by the end of 2021. Based on Elon's tweet, it sounds like we're not going to be seeing any significant semi-production this year, but there's still a chance that we could see limited runs. But 2022 is the more realistic timeframe now. The production delays will get resolved eventually, but let's take a look at how well an electric truck like the Semi stacks up in other areas like cost. The expected price for the 300 mile range Tesla Semi is $150,000 up to $180,000 for the 500 mile range version. And the reason many companies are excited to buy it even at that price, like Pepsi, is because of the expected $200,000 savings in operational costs. But I'll get into that in a minute. Besides Tesla, the top truck seller Volvo Trucks America is also developing a zero-emission truck. The Class 8 Volvo VNR Electric has a 264 kilowatt-hour lithium-ion battery pack that can provide a driving range from 120 to 150 miles and be charged up to 80% within 70 minutes. They're expected to start producing the VNR later this year, and while it's rated up to about 33,000 pounds and doesn't have the same range as a Tesla Semi, it doesn't need to. It's a great fit for local pickup and delivery applications, coping with demanding routes with many stops, all in a single charge. It has a different use case, but for those bigger loads, they do have more options coming, like a 66,000 pound and an 82,000 pound variant. But for now, we still have no prices. Another company is Freightliner, a brand of the Daimler Group, which also owns several companies including Mercedes-Benz. The Freightliner eCascadia semi-truck is a 100% battery electric that can haul up to 82,000 pounds with a range of about 250 miles on a single charge. Its 475 kilowatt-hour battery, which is another big boy here, can be recharged to 80% in about 90 minutes, and Freightliner announced that the eCascadia is entering in production in 2022. The company is also developing the EM2 model, a medium-duty truck for lighter loads, which is about 26,000 to 33,000 pounds, with a 315 kilowatt-hour battery that can go 250 miles. But unlike the eCascadia, this model already has an estimated price of $400,000, or 4 times more expensive than the diesel-powered Daimler M2 that it's based on. Yikes. That much higher cost is a good transition into how they compare to traditional diesel versions. The best way to look at this is the exact way the companies buying them will, from the economics perspective. So let's take a look at the Tesla Semi as an example. And for our conventional diesel-powered semi-truck comparison, we'll be using the 2021 Peterbilt 579 Sleeper. This truck features a 500 horsepower engine and costs $146,000, while the 300-mile and the 500-mile versions of the Tesla Semi cost $150,000 and $180,000. Although electric trucks have a higher cost up front than diesel, it's the operation cost that we can see real benefits. But to start doing the math, we need to understand the baseline. According to the Federal Highway Administration, long-distance trucks can cover up to 100,000 miles per year. Semi-trucks get around 6.5 miles per gallon on average, and the current average price of diesel in the US is $2.86 a gallon. And according to Commerce Express, a semi-truck can last 750,000 miles, but some can reach all the way up to 1 million. Considering a 6.5 miles per gallon efficiency and 100,000 miles per year coverage, we've got 15,385 gallons of diesel used a year. Since the current price of diesel is $2.86 per gallon in the US, the annual fuel cost is $44,000, or about 44 cents per mile. For some international comparison, in the UK, where diesel is significantly more expensive than here in North America, a liter of diesel there costs about the equivalent of $1.79, meaning it's about $6.79 per gallon. And I'm sticking with the gallons and miles for the sake of an apples-to-apples comparison. Metric is the true measurement system, yes, but it doesn't matter for this comparison. I just want to keep apples to apples. Now this adds up to about $104,000 a year for a traditional diesel truck in the UK, giving us a $1.04 mile, a little over twice what it is in the US. When Tesla unveiled the Semi, they stated that the annual energy cost savings would be about half that of diesel at about $19,000. But that statement was based on a price of $2.50 a gallon for diesel. It's a bit less than the current $2.86. So that $19,000 with today's diesel price means about a $25,000 savings in the US, which is about 56% of a reduction in cost annually. Still, considering the average cost of electricity and the annual energy usage of a Tesla Semi, we end up with a 1.99 kilowatt hour per mile. The cost per mile in the US would end up to be about 19 cents, while in the UK, the cost would work out to about 39 cents. So a Tesla Semi in the UK would cost about $39,000, saving about $65,000 on diesel. That is just kind of nuts. At the Tesla Semi unveiling, they presented a total operating cost of $1.26 per mile against $1.51 per mile for a diesel. But there's more to operational costs than just energy savings. Usually when we talk about the benefits of EV over gas, yearly maintenance savings comes up as another area, but it's not clear cut for the Semi. If you factor in operation costs from FreightWave's sonar to our calculations, you're talking about things like driver's salary, trailer financing, repairs and maintenance, truck insurance, permits and licensing. Half of the recommended maintenance tasks for a Class 8 truck aren't related to diesel engines at all. For instance, tires are one of the major costs. So for the most part, we have to consider that the electric trucks will have close to the same maintenance costs of a diesel truck. Adding up all those expenses to the cost per mile for fuel and energy, we'd get a total operating cost of $1.79 per mile for the diesel and $1.54 per mile for the Tesla Semi, at least in the US. And in the UK, the cost per mile would be about $2.39 for diesel and $1.74 for the Tesla Semi. So in factoring that maintenance might remain the same, electric still comes out on top. Yet one of the biggest questions that remains for electric semi-trucks is, will there be enough range day to day? According to the hours of service regulations for the Federal Motor Carrier Safety Administration, the good old FMCSA, truckers are allowed to drive a maximum of 11 hours per day. And considering that a trucker will drive about 55 to 60 miles per hour on average, at the end of an 11-hour shift, they could drive about 600 to 650 miles a day. Of all the models that we've covered, only the 500-mile Tesla Semi can come close to that. But electric isn't the only option to get off of fossil fuels. And this is where it's going to get a little controversial for some of you. I'm bringing up hydrogen. Some companies like Hyundai and Mercedes-Benz are developing hydrogen-powered trucks utilizing fuel cells. And fuel cells introduce oxygen and hydrogen to a catalyst generally composed of platinum, which starts an electrochemical reaction that produces electricity, heat, and water. The electricity is then used to drive the truck's powertrain. At the end of the day, fuel cell trucks are still electric trucks and use batteries to manage energy generation and storage. The big advantage of fuel cell trucks is that they can achieve a longer range without sacrificing payload, since they have much smaller batteries and hydrogen tanks that can pack more energy density. Not to mention the faster refueling times. Charging batteries takes hours in an electric truck, while filling up 120 pounds of hydrogen can be done in minutes. But there are some big challenges with hydrogen. Right now, it's more inefficient to use electricity to make hydrogen, which in turn is converted back into electric power for generating torque, rather than just filling up a battery with electricity from the start. In addition, hydrogen is primarily sourced from natural gas right now using something called steam reforming. So while it's a zero-emission fuel while powering a vehicle, it creates carbon emissions during hydrogen production, although less than actually using diesel. But that's starting to change with green hydrogen, which I have a video on if you're interested. Some examples of fuel cell semis come from Daimler with Mercedes-Benz Gen H2 truck that can travel up to 621 miles on a single tank, which is much closer to the range that a trucker uses every day. They expect to start customer trials in 2023 and enter production sometime in the second half of the decade. It's pretty vague right now. A more current example is Hyundai, which is currently testing heavy-duty fuel cell trucks in Switzerland right now and plans to start selling them in the US in 2022. And you probably noticed a little trend that most of these truck companies seem to be releasing trucks in 2022. And before anyone starts chiming into the comments that fuel cells are stupid and takes additional infrastructure that doesn't exist, neither path has a significant leg up here. Electric trucks are going to require all new infrastructure too. Tesla superchargers aren't capable of delivering the massive power that these battery packs will need for fast charging. That's why Tesla's designed a new charger specifically for this purpose called the Megacharger, which will be much more powerful than current superchargers. In fact, Tesla and a few other companies are racing to produce a greater than 1 megawatt high-power charging standard for electric trucks within CharIN, which is an industry association behind the CCS standard. Bottom line, there's all new infrastructure that's needed to support battery electric trucks. Both electric and fuel cell options offer viable solutions as diesel alternatives. Both require new infrastructure to support operation with either fuel cell stations or megacharger installations near truck depots, so neither has an advantage there over the other. But unlike passenger vehicles, it's easier to target those station locations because trucks typically have set routes. With Hyundai already testing fuel cell trucks in Switzerland and Pepsi testing Tesla semis later this year, it's clear the age of electric trucks is coming soon. And the operational cost advantage of electric over diesel is going to drive adoption in a big way. So when do you think we're going to see a flood of electric trucks hitting the market? 2022 seems just like the tip of the iceberg to me. And who's going to be the first major player? Jump in the comments and let me know. If you like this video, be sure to check out one of the ones I've linked to right here. Be sure to subscribe and hit that notification bell if you think I've earned it. And also check out my follow-up podcast that I do each week about these episodes called Still TBD. And as always, thanks to all my patrons and to all of you for watching. I'll see you in the next one.